Preparing to live stream the meeting. It's all right. I think we are close to being live shared, or it might be starting. There we go. All right. Hello, everyone. Welcome to another episode of Amplifying F#. I'm going to go ahead and share my screen. All right. Today, we are joined by Peter Semkin. We're actually going to be talking about the F# Visual Studio tooling. And I'm looking forward to seeing what we're going to be experiencing today. Before we get to that, let's just kind of talk about what Amplifying F# is. Amplifying F# is an initiative to help hands-on collaboration with the F# community. And so we focus on pretty much anything in the entire space of F#, meaning that we'll do tooling, we'll do any open source projects, anything kind of related to F#. You can actually come to see some of the previous sessions that we have that we've done in the past. And if you come over, you can actually click on the sessions in the upper right. Last week, we ended up doing a session with Florian on Pelplin, which is a tool for generating signature files for F# source code. And we ended up covering one of these issues. After we covered the tool a little bit, we covered one of these issues about that was needing to be worked on. And so we ended up working on that tool or working on that fix and submitted the pull request. And he's a maintainer of the same library, so you can submit or pull or take his own pull requests. But a lot of times, other sessions, these pull requests are submitted to repositories that people do not own. And so, if you're looking to actually help be part of Amplifying F#, we actually have a form that you can click on at the very beginning. There's the Join Us Today button. You click here and you can give us your name, give us your time zone so we can help scheduling, figure out what you want to work on. And this is basically anything in the F# community. If you want to work on something, or even if it's something that you want to showcase that's really good for the F# community. Like today, we're going to be talking about F# Visual Studio tooling. And with that, I'm actually going to turn it over to Peter.
Hello. Yeah, thanks. Thanks for passing this by to me. I'm Peter. I go by DS Tanake on the internet, Twitter, GitHub, wherever. Back in the day, I thought it's cool to have a unique name on the internet. Now I don't think so, but it's too late. So I'm, hang on, I'll share my screen. Show where I am there. Yeah, that's me. I have this sheep avatar everywhere because if you look closely, I'm similar to that guy. Yeah, so that's me. I'm a bit nervous, so I'll talk about myself first. I've been in software development for a while, mostly C#. F# was always like the language for me. So in Microsoft, I'm for 3 years here. So, and for a year working in F#, once they opened like a position, I was like, yes, I'm doing this. So a lot of smart folks in the compiler space. Before I was doing a lot of just deep backend development. A lot of smart folks there as well, but I feel that like compilers are extra hardcore thing. So yeah, whatever. Today we'll talk about editor, Visual Studio editor thing, which, as the announcement says, indeed is open source and even like in the same repo as the whole F# language. I actually don't know why it's like that, but that's like this, so it's fine. I've been focusing quite a lot on that, actually, probably because I was doing so much deep backend things that I wanted to finally do something that I can see. like any output, anything. Even though it's like developers for developers, still it's better than like whatever I was doing before in that regard. So yeah, I'm still learning a lot. F# code base is huge and has a lot of historical artifacts there. So I'm not an expert by far. I have some folks from my team here who might help me at some points, I guess. Feel free to ask any questions whenever. Stop me. I'll try to not do too long. It's Friday, and I watched some sessions by Amplifying F# on YouTube, and they were marked either by Amplifying F# or by YouTube as entertainment category. So I'll try to do this as much entertaining as I can. Yeah, so that's for the introduction, I guess. And as for the editor itself, yeah, let's just go through the code base a bit. I will bring it to the screen. Hang on. Yeah, let me just close. Oh. Okay, so
I think you might be
that's
sharing your Chrome window and up,
yep.
or it's just really slow.
Here it
There
is.
we go.
Yep. So that's just code base. And there is this source folder where like compiler sits, all this kind of stuff, and tests for that. But there is this VS integration folder where it's like the whole brand new world of the Visual Studio development on top of F#. And it has itself source and tests folder. Again, I don't know why it's split like that, but that's like this right now. And then it's basically what you expect, some effort to split the code by folders, by projects, by whatever. We'll be mostly looking into F# editor project and also F# editor tests. Those are supposed to be unit tests. There is also a thing called integration tests. We are still figuring out if we really need them. What we really need is actually testing. I'll get to that. And here, well, if you work with Visual Studio or any big IDE, and you're familiar with like .NET space, then kind of you can guess what all those things are supposed to mean. That's basically whatever the editor can provide on top of the language, on top of the compiler. So some things I have looked at, some I haven't really properly. But yeah, basically code fixes, we'll be looking at code fixes here today in more detail, completion, all the intelligent stuff, formatting. Yeah, that's basically navigation, quick info, different capabilities. Again, tested and used by various extent, some a lot, some not really. So but anyway, that's open source. There are ways to see this, to test this, to check this locally, and this is one way to actually show your work to the world, because once the things are merged to that place, like it will take some time, but eventually Visual Studio will be released containing these changes, and you'll be glorified in the Visual Studio notes, release notes, or whatever. So, but anyway, a lot of people will actually thank you for this, because a lot of people use editors, I mean IDEs for development, and are helpful for any way to anything that improves their productivity. So yeah, one thing I was actually looking more extensively back in the day, and still now, I was looking into this hints things that something it's off by default, I guess. Still, we might switch it at some day, but that's basically that thing that shows in theories. Well, basically hints, the types, the parameter names, and so on. So I basically brought it, um, well, not entirely from scratch. I was inspired by how we had in Codelands and whatever C# has, and a lot of things. Basically, the thing is that we here build a lot on top of Rosslyn. I will get to that, on top of the .NET compiler. And once you figure out how things are connected, it often breaks down to the fact that you need to find just like some interfaces to use, and then just, work with text, basically do some replace of some symbols. That's what a lot of this code is eventually about. It doesn't seem like that, but like eventually, like the core logic is you just work with text, well, which is what is, you know, uh, programming language is about. So with hints, one thing that I'm trying to do a lot now, I try to democratize the Visual Studio Editor development, because that is to make it easier to contribute. Because now for most of the things, you just need to manually test things. Uh, like open this huge Visual Studio instance, run it, see that it's working, and so on, which is, well, for one, is annoying and takes time. And another, for me, it's just like morally wrong. Maybe that's because I was working in SDKs for so many years, and like in a culture of testing everything extensively. So maybe it's just, my thing. I like testing. I talk about testing whenever I can. So yeah. Um, so I tried to make this hints development back in the day contributor friendly, and that worked because a lot of members of, well, not a lot, some of the members of the community actually joined and helped fixing some bugs and bringing new hints. So that said, I was doing all this testing framework there from scratch, just, trying random things out. It's definitely something you can iterate on, something we can improve, and so on. As long as the intentions are good, it will be fine. Yeah. So let me bring some Visual Studio here so that I can at least show what I'm talking about here. With hints, it was yeah, that kind of thing. So it shows, those little inferior types, which are usually, well, often more useful than that. Same for parameters and so on. Still, there is like a lot to improve in that space. We want to make them like, on a click toggle basis. So one day, and just make them less noisy, all this kind of things. Once you kind of start looking into that, you just see so many opportunities for improvement and so on. So that's actually cool. And that all helps a lot of people. Yeah. So what I want to talk today, so that we get hands dirty a bit, I want to talk about code fixes. That's what I've been doing extensively since the beginning of June. We have had some improvements in code fixes recently. You know what's code fixes is like those light bulbs. I will show that soon. That suggest you improving something, fixing some errors basically automatically. We have quite a few of them, not as many as C# does, but like still quite a few. With bugs, we have bugs there, but some of them are quite reliable. And again, like there were some contributions recently, and always it wasn't like really, it was just like screenshots with things kind of working, but it's a very subtle matter. All those code fixes, it's easy to break things, and my latest investigations prove that yes, a lot of things are broken there. And that situation was just breaking my heart, that like we don't have way to test them properly. And one day I told Vlad, hey, like just hey, I want to take a few weeks and you know, democratize this. This is what I call it, so that it's easy to develop, so that like people want to develop them, and not just like file issues about them not working. So that's what I'm trying to do right now. I'm basically in the middle of it right now. So I'm building some test framework. It's still quite raw. We'll see where it goes. But as I say, we can iterate on that, and I will show it today. So I will talk about what we have on GitHub later a bit, but like yesterday, I spent the whole day of bringing everything about code fixes to one ticket, kind of tracking ticket. Yeah, a lot of stuff. I marked some things as good first issues also. But anyway, there are a few bugs. There are a lot of ideas what we can do. We can also borrow from some ideas from Ionite and FS autocomplete and from C#. And that's actually what I want to do today. I want to steal, or how do you call it? What's the correct way to say that?
Be inspired by.
Get inspired, exactly. Get inspired.
Keep in borrow from.
Yeah, get inspired by FS autocomplete. So yeah, one thing, technical stuff. We have this special. We have a few solutions in the source folder of F#. And I created this special solution called, because like the big ass F# thing is like 70 projects. It takes some, it's not as horrible as rostering, but still it takes time to load all that kind of stuff, and you can be annoyed just by that. So I created this F# editor solution, which is only like 8 or 9 projects. So it's a bit more bearable. And that's what I have open here somewhere. Hang on. Yeah. So let me just bring it to the screen. Sharp editor. Yeah, as I say, it's I guess it can be further split, but like as of now, it's sort of better. So you cannot run this. You cannot. That's basic libraries and tests. But that's the goal. So that like you can just write unit tests and test things in that solution, at least at first. Yeah. It's called Sharp Editor S1. That's pretty much it. So I was looking at what does FS autocomplete have that we don't. And hang on, let me bring their code here as well. I have a lot of editors today, and I might get lost there. But basically, what I found is this, yeah, a lot of code fixes in FS autocomplete. Good job. Some of them are tested, but also I saw a lot of opportunities there. Let's put it this way. But one thing that I was surprised that we don't have actually in Visual Studio is this one. You know, you have the record. Well, actually, we can demonstrate it all. Let's do that. This is just some random playground project. So we have some type, I don't know, band, and it's simple. And we write this, and well, those who work with F# on daily basis probably won't write this, but that I can imagine this happening for like newcomers and people who switch between C# and F# every day. So, and that's an error because there should be a colon here, and yeah, F# Visual Studio doesn't do anything, on that, and kind of whatever. IONITE does. Let me show this here. One more editor here. Damn. I don't work too much with Visual Studio Code. How do I increase the type here?
You like Shift plus, or is it Control Shift plus?
Oh, yeah. Thanks. Yeah. Okay, that should be enough. So IONITE has this. Oops, no, not that. But basically, there is this quick fix. Use colon with that field definition. Yeah, that's right. So what I will do, I'll try to do the same for Visual Studio. The code will be a bit different apparently because like the framework is a bit different, but like, you know, it should be relatively easy to do judging by just what is here. It's relatively doesn't seem too hard here. So where we start, a good place, you know, I will show an example of a good developer today. Try to be end-to-end. A good place to start is like GitHub. It's just to see if anybody has already tried to do something like that. And if not, create a ticket. You can create PRs right away and they might get merged. So, but like, you know, just putting a ticket down there can trigger some good discussions and insights, and you can just like form your thoughts here. So I'll actually go ahead and create a ticket. Maybe just a stub for that. That's kind of feature request. I will get to GitHub later, but I created, or we actually had this label for code fixes where you can find like all those tickets open and close and whatever. So but what we have, actually, we can for now change equals in the field type to colon. Yeah, that sounds like a good name. We can probably just take it. Yeah. So create a code fix to change equals in field type colon. Yeah, that sounds good. And just show what we want to do here. I will glorify it later a bit, but you know, good enough for now. At least at that point, you can think about its name. So if you don't have, because naming is hard. So maybe call it what was there. This thing. Good enough for GitHub. That will already notify a lot of people and maybe spark some conversations. So that's fine. Now as we have the name, we can start developing it. Yeah, let's be, you know, those, let's try to be TDD here. We can start by adding some tests, and there is something to get inspired from already. And I think because we are inspired by FS autocomplete, but we're not copy pasting things. I wonder if there are no tests in FS autocomplete, so or I cannot find them. So we can try to be better, at least in Visual Studio, so that they can.
I want to double check and just look for the name of that being used somewhere, because we do have tests, but I don't know if there's a test covering this one specifically.
Yeah, I found like just a few actually.
Okay, because there is the tests, and like I think a lot of things are just shoved into tests, which I don't know if they're actually. I think there's just a lot in here. Yeah, I don't know. It might be hiding somewhere in one of these or in this file.
Yeah.
Might not be
Okay.
though.
Okay, but the test case, at least in that case, is quite easy to write. So yeah, I just want to say that like if there are no tests in FS autocomplete, at least they can later borrow it from us, because it's all open and we'll be only happy to share it. So let's add a new item, tests. So I try to make it as easy as possible, because that's what tests should be. Like everything, all the dark magic should be hidden somewhere in some framework. Therefore, I'm like creating all those test frameworks whenever I can. But they currently look basically what you expect as a developer. Hopefully that like you have broken code and like you press a light bulb and like Visual Studio fixes the code for you. That's pretty much the framework. One thing here, I mean, code fixes. There are a few concepts here. There are code fixes, there are code actions, there are also refactorings. That's all basically refers to a bit different things. There are like light bulbs, and then there are like those how you call those instruments that just offer you refactoring the code. So the mechanisms are similar. Again, eventually it's just tied somehow to Rosling interfaces. You inherit something and you implement whatever they ask you to. And that's more or less documented, at least like for C#. So because they want to encourage people to do that. But I'll probably eventually also write something how to write a code fix for F# later once we have things more or less stabilized. But why I'm saying all that is that code fixes in particular, they are tied to diagnostics. That's one important thing to realize here. It's like you have the error, and code fix is triggered just by this error. So it depends on how broad is the error. You might want to filter scenarios. You might want or not want to offer the code fix for this error. So you need to be sure that it fixes it the way I want. So we'll get to that, but that's why tests look like this here. You have the broken code. You need to say what diagnostic you want to trigger the code fix for, because same code fix can be also triggered for multiple diagnostics. And that might fix it or might not. It might, code fix can understand that actually that's not what it can fix. So therefore, I have in the latest iteration of the world, I have this try fix method, which returns option. We'll get to that later also. Anyway, let's write some basic test here. whatever. Yeah. I'll do some live coding here. I could copy paste everything, but you know, I like live coding for some reason. So now we don't have this type yet, but we already can figure out the diagnostics we are talking about. It's 0010, which, I mean, my observation, which might not be correct, but like if the number is so low that like this is a very basic diagnostic and it might trigger like for a lot of things. So that's just, you know, something to keep in mind. Anyway, unexpected symbol. Yeah, okay. So we at least know the number for the error that we want to trigger it for. Unexpected symbol, whatever, that's just for us. Yeah, now we use XUnit mostly. Like in this project, we use XUnit. In some other test projects, we use NUnit, which is bad. I mean, not that NUnit is bad, it's just like bad to have multiple frameworks. I'm like, whenever my brain hurts of doing like hardcore things, I try to rewrite some tasks from NUnit to XUnit. Maybe artificial intelligence will help us all like some of this. So because it's all very dumb work. Anyway.
Hey, Peter, could you bump the font up on these?
Oh, sure. Better?
Yep. Thank you.
Yeah, sure. Okay, so whatever. Let's have the broken code here that we want to fix. Where was it? Yeah, one thing that makes as development happy for me is that I try to include musical examples everywhere I can. So because I like music. So and you can have whatever in test strings. That's my personal motivation. One of the parts. So we expect the code to be fixed in that case. So this option that I have should actually be something. The message, we can think about it, or again, get inspired. So the code will be same, but with a column here. Okay. Yeah, and that's basically it. You have this arrange, act, assert principle in test development. So I try to apply it here. You know, I'm missing something here. Hang on. Code. By the way,
semicolon
yeah. Yes, like this. This is right. Indentation, probably. We have the Antomas plugged in for editor. So it will fix the code. If you ask, or if you don't ask, it will also fix the code eventually. Yeah, that's it. That's the basic case here. So we have at least what we want. Well, we can also think of the message right now. I don't know what does fs autocomplete say. We can see. Yeah, fair enough. Those messages depends on the code fix. Like, there are ways to make them more specific. There are ways to use, like, actually take like the part of the message from the code. So, but here it's probably not needed. Like, it's as long as you show the code fix at the right place, it should be more or less easier to understand what's this about. Okay. So that's the test. Now let's write the code fix itself. Hang on, let me just create the. It depends on how fast we are. We might get to the submitting APR, or might not, but I'll create a branch anyway. Code fixes 3, 4. Okay. I've been working for a while in this space. Tests don't compile because yeah, because this whole thing should implement this interface. We'll get to that. Okay, now it compiles. Okay, still creating the branch. Do you have any questions as of now? Okay. I'm already a bit disillusioned with all this like code fix development last 2 weeks, so I might be skipping like some basic things which are important to understand. So yeah, whatever.
Quick question. How would you, so is it when you add a code fix error message, is that going to be translated automatically by the CI or something like that?
Yes, we'll get there. We have localizations, maybe about 12, something like that, 14, about a dozen. There's Czech there even for some reason, and 2 versions of Chinese, I think. But basically, you'll see how that's happening. You won't need to translate it yourself, but there'll be like auto created some stubs in some resource files, and then a bunch of I don't even know if people are doing this or robots are doing this, but eventually there will be like a PR coming up to our code base that will actually translate all those things, and they will appear in the language of the environment. So I don't know. I mean, when I look at those translations, they don't feel entirely artificial, but like sometimes they don't make sense. I don't know. That's a different question. You can always help there, I guess. And apparently some people are using the IDE in the language of not different from English. I think we have had recently some bug because of the Chinese localization. Kevin was probably fixing that. A lot of fun. Anyway, I'll show that later, how this all happening.
Thank you.
Yeah. So we have the tests. Let's create code fix itself. So we create we have this folder, and it's too lazy to type this again. So yeah. Again, I could copy paste things, but I want to explain something on the way. So why some things are looking the way they are. So I'll just open something here. I don't know, something I've recently worked with. Oh yeah, there is this change to upcast thing. So yeah, we can. I'll get to cancelable tasks soon because that's quite new in the compiler, and well, not in the compiler, in our code base, and that's a cool thing. So you need to have this. You need to implement this interface code fix provider. So that's the interface from the Roslyn, basically Microsoft Code Analysis. And the way, and therefore I'll call it code fix provider. Now, the way things are actually tied up together is that, well, there is this thing called MEF, which stands for, I think, Microsoft Extensibility Framework. Honestly, to me, it's still very black magic and voodoo. That's basically all I know. It somehow connects things to Roslyn, and but that's a mechanism we live with, for better or worse. And therefore, some things we're doing are actually related to that. So therefore, we need to use some attributes and whatever. That's basically to plug things together. Again, once like I'm creating all this test framework and like framework for code fixes, I want to minimize this like effort of understanding why it's like that and hide it somewhere. But we'll see how successful I go. Math is everywhere. So yeah, but that's part of it. We have to add this attribute, and you see these things like all over the source stage. But at least again, it's just an attribute that shows what it wants. So we need to come up with something called name for the code fix, something to distinguish it. And that's a constant. So let's create it. Okay. And hang on. Yeah. Like this. Okay. So okay, I hope it will compile later. Now, yeah, okay, all good. So this interface that we are implementing, well, it shows you what it wants, but basically it's quite small. You need to have this fixable diagnostic things. As I say, code fix is bound to a diagnostic or to a few diagnostics actually. So, and what's important, I don't know, what's important here is that all those diagnostics which the code fix is going to fix should have the same span, like the same place in the code they are triggered for. So I don't know what happens if they don't. Something will explode. I don't know what exactly. So, but that's something to keep in mind, that there can be like multiple diagnostics here. Therefore, array here. Now, and another thing that is here is another thing that we override is this, probably the only method, I guess. Register code fixes, I think, whatever. So we have some context here, and that's well, we'll see it when we get to debugging here, but that's basically everything that we know in the process of like triggering the code fix. And that's a lot. We know like the diagnostic, we know the span, we know the message, like basically the document. So actually whatever you might need is quite a rich thing. So now this is actually an extension method that I created another day exactly for this purpose, to just surface a way this plugging things together. But that basically eventually here, this is just like some helper stuff that eventually does create code actions. This is code analysis. This is rustling APIs, and calls the native, or rather native methods to do that. So eventually it creates the code action for that, and therefore triggers the whole thing to the light bulb, plugs the whole thing to the light bulb. So as of now, that will probably again change a bit, but that's just a helper method I created to not copy paste the same thing over and over. What I created also recently is this actually interface with the whole logic of fixing stuff. So, and that's also subject to change. But for now it has, well, you know, I tried to build some F# friendly stuff on top of whatever Austin provides. So that's a pure record, and this method, this function basically works with document and the diagnostic span, and brings something called cancelable task. I will get to that, but eventually offers this thing. So yeah, and that's what we want to implement, and that's what is available from tests, because we don't have the whole Visual Studio, the whole rustling context right away in the tests. It's a lot of things there, you'll see, but like what we have document, we can write ourselves our tests the way that we have the document and the diagnostic itself, at least. So we can have part of it. So, and I call the method currently get code fix if applies, because as I say, it might apply, it might not. Cancelable task is something that we recently merged to the code base. It's based on iced tasks, or maybe just copy paste it. So, but anyway, that's our latest and greatest, as far as I understand. That's our latest and greatest thing in the async world. It eliminates some boilerplate, and we are probably gradually rewriting things to use it everywhere. So it's you'll see why it's nice, because basically you don't have to specify tokens everywhere, but you can pick them from the environment when you need them actually. So, but that's otherwise very similar to async or whatever monads we have in that space. And we have the document and the span, the diagnostic span here. So what we need, hang on, I'll just make this compile. Okay, so that's the skeleton of our changes, and we can already get here. So I'll actually commit this as like top for everything. That's when we can actually start running our tests and seeing the information that's available and thinking what we can do. So let's do that. That's, as I say, I might be a bit obsessed with testing. I just like the way it looks right now. You have tests here, the logic here, and I wish I could spend like a lot of time with this environment, just like seeing those things close to each other. Anyway, let's debug this.
You probably want to replace the fill with on line 10.
Sorry, once again. Yeah, all right. Okay. Yeah, thanks for this. We already can do that. Yeah. Yeah, now since we have the interface, we can specify it here. Yeah, it all compiles. All good. It's still building. Yeah, I mean, it doesn't build as long as the whole F#, but like still builds some time. Takes some time. So yeah.
While we wait, I recently learned that ice task is created by Jimmy, which is in the code as well. So really good to see a cross pollination of different projects with the F# compiler tooling, FSO complete and all that stuff. So yeah, this is really awesome.
Yeah, that's really amazing. It took me some talking with Vlad to get hooked on that, but eventually now I am. So it worked. Really great stuff. Thanks. Thanks for that, and hopefully it shows that we try to be a friendly community here and borrow ideas. That's all very useful. So but that's like one thing, if you just like want to help a bit and get your hands dirty with the code base, you can like find some async code and like rewrite it using the cancelable tasks. Or we have like other monads we are trying to get rid of, like async maybe, well, probably not everywhere, but often it like rather confuses than helps. So that's what I'm also doing like along the way, because a lot of code fixes are written using that technique. Are we debugging here? Hopefully. I already I'm moving the code fixes to use this framework that I'm creating so that they are testable. I moved like a few simplest ones, found some bugs on the way. So, and there is like still a lot to do here. So if anybody wants, I will appreciate again, like any help here. So we are here. So what we have, how much this is visible? Yeah, but basically, we are inside the code fix, and all right, it's here in one. Okay. Let me do it once again. Yeah, okay. So that's as expected. That works. So what we have here is I just want to get inside the code to show the context. So bear with me. Also, as for the fix itself, you'll see that eventually we'll need to just replace one character. So that hopefully should be, yeah, easy, as I said. I don't know why it takes so much time, because it basically only rebuilds like the editor. As I say, we have a lot of opportunities in the compiler code itself just to make things faster on different levels. And that's actually what a lot of people are working on, also like in our team. So, and I think things are gradually improving there. But we can probably have like a session about performance of the whole compiler one day. That would be helpful. So okay. On. Okay. So we have the document. We can easily get the source text from the document, which we'll probably do. And we have the diagnostic span. It shows basically that thing where the red squiggly line pops up. So that's one character. And Rosling has its own way to calculate the span of things. F# has yet another way to do that, as far as I know. And there are like all sorts of conversions, but that doesn't, well, it matters often, but like here I'm just saying that like we have this one symbol here in the context of the code fix. So therefore what we need to bring the updated well, not the updated version of the document. That will all be done by the framework, but we want to say what we want to fix actually. So we want to create this record that we define elsewhere. That's name. Changes, I will get that. And we are missing the title. So the title is something that actually Visual Studio shows you and suggests the code fix. For me, it was just like confusing here. Thanks a bit. So in the record, I call this message because that's like the message shown, and like then there is like also name of the code fix. Anyway, calling variables is hard. But that's that thing, where was background? Use for type and field declaration. That's the title of the code fix. So the name and the message, like in the framework, the name of it is like just something for internal purposes to distinguish code fixes like from each other, like on the type level. So yeah. Anyway, we need to have this here, and that's where all the localization things kick in. Yeah, we have. Well, it will be actually useful to show how this all is created. It's like a lot of, well, not a lot of, some boring work basically, but not too bad. So we need to create this message here. That's sharp editor fs. I wonder if this is generated. No, that's, yeah, this is generated. Okay. Right, resources file. Yeah, that sounds about right. Okay, we need to create another thing here. And in English, so change, yeah. And we have this proposed message there. We can copy it here. Well, I wonder if this worked, because, well, I hope so. We'll see.
It's
Here it
the
says,
field swap to
yeah,
the operator.
yeah, sorry, it should be here. We'll see if this works. Okay. So once I have it here, and if I try, let me try. I haven't done it for a while, but basically, once we compile things, there is something to trigger creating of all those localizations there. Not yet. Yeah, okay, there you go. So we created the right thing, hopefully. So we created it in this resources thing, and just triggered the build, and it created those like translations files, which are marked like that. You have like the source, target, and it's marked new here, so that people who are, or robots who are translating this, they will like find this and translate that and create the PR. So that's not your job, but that's like just how things are marked there. So that will create automatically. Sometimes you see some PRs and they are like 30 files and you get scared, but then you see that 16 of them are just translations, and that calms you down a bit. Yeah, so that's there. This didn't get generated as far as I see. So I'll probably do it. I can. So that we can use it in the code. I wonder if this could be further automated, but that's how things are now.
I think if you find the file in the Solution Explorer and right-click it, it has something like Run Custom Tool, and that will possibly generate all the stuff.
Wait. It actually got generated. Right. No, that's. Oh, I see. That's because it's already generated files. Sorry for confusion. That's already an artifact. So that got generated, and we can. It's just like not in the source control. So that's all fine. I guess we can use it right now. Okay. So I probably created in the right way. Hopefully, at least that's one way to do that. So there we have it. And so now the only thing that we need is actually define the change that we want. So and that's using again some rostering stuff, text change, but eventually that's just an operation on top of source code again. So we have I think it wants yeah, it wants text span, okay, which is basically the point of insertion of the new text and the length of it. So what you want here, you want to insert it just where the diagnostics pop up. So right here, but insert it for the length of one symbol so that like it rewrites the equal signs. So therefore, I think, yeah, that's how I specify. So that's where you insert the new text, and then like you also write what you insert.
What if someone writes a different operator there, like 2 equals or something? Will it get the same diagnostic and we only rewrite one? Or
yeah, we'll get to that. That's not the eventual thing yet. But as you'll see, like in the span, basically, whatever you can imagine that as like just what is shown for the red squiggle thing. So if that and this is, as I say, this is like a very general diagnostic. So it can be here as well. So for, I guess, whatever is not supposed to be here will be here. So it will trigger the same thing. So therefore, that's not how things should be eventually. So, but just a way to start here. So, and to fix the initial thing. Test case. So that, I think, should be enough to cover that particular case, and your point will get right after that if this at least like passes. Let's see. But as I say, the FS autocomplete has a condition here, and that's for that particular reason that like we should filter the cases that we have here on top of that. And that's basically, that shows the diversity of the code fixes that we have. Some of them are like they don't have any conditions whatsoever, like that one. Add instance member parameter, because that's quite a specific diagnostic, and at least what we know about it, like it can only appear like in that, at least like that's what the code says. It can only appear in that case, and we can be safe that like it will always help. But some code fixes are like hell complicated, and I'm scared even like to look at them. Add type annotation. Yeah, a lot of things are going here. We are asking parser for a lot of extra information to understand where we are and what we want to do. So that can get like quite wild there. And yeah, that's what I was talking about. Like I think maybe and that's a very complicated thing here. Like it reacts for a few diagnostics and it doesn't seem like that, but like that's the thing with I think maybe that actually some things here are options and built on top of options. So there is a lot of filtering going on. It's just like not very obvious like on first glance. That's like asking for bugs here. Like that should be tested. So I'm actually quite sure this is a bug because I like this thing because there was a similar code into other code fixes with bugs due to recent refactoring, which happened to be a bit more sneaky than it looks like. Anyway, so we have this test passing. So we are in the TDD loop. That's fine. And let's celebrate it. And probably before, as pointed out, this is not ready. So because we don't filter anything, I'll just finish it with like writing some breaking test as a reminder. And then we can get to questions and other stuff I want to share briefly. Yeah. So, for example, I think, yeah, what I so that we are, yeah, that triggers the same thing. So we expect none here. We expect this not to happen in this case. Code fix to React, but it will now because we don't have any filtering. I'll demonstrate it, and that will be good enough for now.
Instead of open, can you use please call on equal?
Sure. Like this. Yeah. Yeah, that also sounds like something that newcomers might write.
Yeah, this slowly leads into the discussion about having diagnostics have more structured data in them.
Yeah. Well, so as I said, diagnostics, some of them are wide, some of them are narrow, and the way I discover, at least for the trigger for, because I wonder how well they are documented, I just usually go around the code for this diagnostic. So we have like component test somewhere. That actually, because that's the compiler thing eventually, and there are kind of those baselines in that sense. That this code that triggers this diagnostic, and so that helps actually writing those like negative cases for the code fixes. That like you look at the code, you see it triggers the diagnostic. Do you think if you need a code fix for this, or if that code fix is supposed to be here or not? Oh yes, there will be a lot of negative cases here. Yeah, a lot of stuff. So okay. Yeah, probably some of them are similar, but that means that we really should to have like a very narrow filtering. I think the way FS autocomplete does it here, it just looks at the message of the diagnostic, which probably is a good way to go. We can probably eventually do the same. We, in many code fixes, what we do, we extract the source text from the document and work basically on top of spans, and sometimes ask like parsers for different the parser for different information. So, but diagnostic message can be actually more clear and intuitive. Let's see. Yeah, that fails. So because the code fix got triggered, and therefore it created this fix, which is something you don't want to happen. So it inserted basically the same symbol in the same place. So it rewrote like colon to colon, and that's useless. So yeah, we have a negative case then. Negative test. Okay, so one thing that I want to show is that like after we write all the tests and you are quite sure about like what is going on, you can actually do some manual testing like before submitting PR, just to well, check if the framework that we are creating is working, and also to celebrate your achievements. So I have this full-blown Visual Studio F# solution here. I will show how it. We have instructions for running that. You can run it using some console flags, whatever. I just opened the whole thing and run this Visual F# debug project, which, well, as you would expect, starts the new instance of Visual Studio and with your changes in. So it more or less works. The problem with that, well, apart from that, it takes a lot of time. Sometimes, in my experience, the DLLs are blocked. Sometimes Visual Studio blocks itself, and whatever weird stuff is happening there, that's yet another reason why I don't want to do this often. So you need to do some weird cleanups of weird things. So sometimes it throws some exceptions that all actually can and should be improved eventually. So, but that works as a way to go. Just mind that it might be slow and weird. And once the whole thing is merged, well, I guess most of the people know here that, like, as I say, it will take some time for things to propagate to official channel of the Visual Studio, but you can use the extension, basically the F# extension right away after things emerge, which is basically like within day 2, whatever. So quite soon you can use like the changes that you brought basically, and other contributors who do that. So that's nice, and actually helpful, because we can catch some bugs along the way before they go to the official Visual Studio challenge channel. So hang on. I have, right, let me just move this to the sharing screen. There is this yeah, okay, here is in dark mode. Yeah, that's the Visual Studio with your changes, and yeah, so now for that case we see this light bulb here, very satisfying moment. Works, didn't throw anything, so yes, but yeah, for that you will also see this light bulb, and that did nothing, and for that it did something even worse. So that's, yes, you can see this in action. So you can play with this already like in this manner before submitting code, and like make the screenshots or GIFs or whatever you want. So yeah, that's probably good enough for now. You can take inspiration from like other code fixes and like from other things in the Visual Studio editor. There's a lot of code of different quality, but like basically you see how things are written, and can that helps. And also, of course, you can always ask maintainers to help, and the community to help. We are trying to make things better here with the compiler, with the editor, and we are friendly and helpful and grateful for any contribution in that space. So that's it. I'll just say that once again, I created this tracking thing. Pick whatever if you want, or just bring ideas what we can do. I will try to make things easier here. I'll also try to bring more colleagues to help with that, so that we increase the buzz factor in that space. So and the more people look at that code and work with that code, the better it is. Like, we need more perspectives. I marked some of those as good first issues. Hopefully they are. So we have labels for different areas. We do the triaging of bugs every now and then of different tickets, so we try to get this more or less in order. Yeah, a lot of tickets actually here. That's a long topic. Yeah, so that's, I think, all I wanted to share for now. If you have any questions, please ask.
More than a question, is an observation. Like if you are in the call now and Zoom call, or you are watching YouTube, and you're seeing that you want to contribute, you want to help implement a quick fix. Now, this has been a perfect showcase of how you can do that from scratch, how to do it from zero. So, and here on Amplify F#, we can help you, to go through that. Now that we have a session we can fall back and learn how to do this. So if you are thinking of contributing a code fix to Visual Studio, not only to Visual Studio, but to any editor tooling, you can tell us your idea, and we can invite in the future if Peter is available or anyone from the team is available to give us a hand how we can finish that. And yeah, the same goes for all the editor tooling like IONI, like FIDA. But basically, we are here to make the F# developer experience for everybody better. And yeah, so yeah, for me it's been amazing. Thank you very much. And I myself, I might contribute a code fix in the after holidays. So I need to first of all clean my mind, and then I will be back.
Sure, my pleasure. And yeah, you're very welcome.
Thank you.
Damien has his hand raised. If you'd like to go ahead, Damien.
Yeah.
Hey, so I joined late. I just, when it comes to code fixes, right now, is this a common thing, or is this Visual Studio specific? And we're in the space where we have like Visual Studio code fixes and Ionide code fixes.
Well, it's quite common. I mean, code fixes are there for many years. They're just, I guess, becoming more popular lately as C# community started to bring a lot of them and promote them and document them. So I guess there are some code fixes for Visual Basic. I saw the folder for them. So, but like that's definitely like a .NET thing, and therefore different IDEs support them. Like there are some in Visual Studio. I showed some in Ionide. I'm quite sure there should be something in Rider, some code fixes there. So with other languages, that probably depends on how a compiler works, and like if there are this idea of like diagnostics and something that can react for that. But that's so that, well, it first helps to people to be more productive, so that like you can have this one click and like the code is fixed. Nice. But I think it's also very important for the newcomers who are used to do things differently in other languages. And in this language, the syntax is just like a bit different. And we have like a few code fixes just for that, like convert C# using to F# open, convert C# lambda to F# lambda, because, well, we have more correct syntax for that. So therefore we created it differently in F#, but like people who either
if you I think my question was more about like with C#, you have Roslyn analyzers that gives you like a consistent framework, but in F#, right now the state of things, I guess, is that we have more IDE specific code fixes than a standard code fix framework.
Well, that's hard to say. It's like Roslyn has the framework, and like just C# code is basically located in the same REPL in a way. So, but there is like the layer of types of the interfaces like that I showed, like fixable diagnostics IDs, and then like different languages in .NET build on top of it. So it's just for C# somewhat easier because Roslyn itself is written in C#, and like you can more or less natively use that. For F#, well, we can use C# code, but sometimes it's ugly. Therefore, like we are creating this like small layer of just like making things convenient for F# development, and that's like the case for different parts like in editor. But basically, some of the code fixes that we have, they are IDE things. So like remove unused opens that reacts to IDE 0001 or 5, like one of the very basic things. But others are very F# specific diagnostics, like this remove, like return, yield, like that's F# I think most of them are actually F# specific. Did that help?
Sorry, I also had another question. If you're inside the F# code fix provider, would it be difficult to do some sort of a check that the diagnostic is really inside of a record?
Well, difficult. It shouldn't be difficult because like you have the parser at hand, you have the type system at hand, and like a lot of code fixes that are there, they do like quite extensive investigation on top of that. I wonder if I can find something right away. So use mutation. But basically, that already requires some understanding of the symbols and like spans and whatever. So we here find the symbols and try to classify them here if they have this or that. So I think we can have like we can ask the parser for the context, like where we are. And I think I saw again code like that.
On line 53, you could get the entire untyped tree and do some tree walking until you double check that the range of the diagnostic is indeed inside some sort of a record.
Yes. So
it's easy to get access to that.
Yes, you have the document, therefore you can parse it, and therefore you can get any information. It just can get, well, not very easy. So, or like it's basic compiler stuff, but like even basic compiler stuff is hard. So you need to get in the context of like symbols and like spans of all this kind of things. But like at least, well, if you write code like that, you already have the results, and you can just like in the locals window see what you have, and start building conditions on that. So you have the information. It's just like the harder, the like broader is the diagnostic, and like the more understanding you need about the context, like the bigger like conditions will be here eventually. So that's it.
Gotcha. Thank you.
All right. Anybody else with any other questions?
Yeah, Thomas wrote in the comments that there are already, in parser ways to get like some specifics, like some context for common cases, I guess. So yeah, and you are very welcome to add more shortcuts like that. I think we created a few when we're doing something for hints there. So yeah. Anything else? Are we good?
I think so. All right. I'm going to take control back for just a bit.
Sure.
All right. Yeah. As a reminder for everyone, if you'd like to join the initiative, come to the join page and you can specify your name and the topic you like. We have a lot of code fixes that we could potentially do, so there's plenty of options to choose from in the F# Visual Studio tooling. As always, the session will be on our YouTube page and in our previous sessions on the our webpage as well. And when you come to our YouTube page, everything will be under the live tab here, rather than just the home or the video tab. And thank you for everyone for joining.